So today we will talk about the units of equilibrium constant, which is basically Kc. The units of equilibrium constant, basically the unit depends upon the nature of equilibrium. Nature of equilibrium, right? For example, like we have to, if the moles of reactant and product are if the moles of reactant and product are same, then we have no unit of Kc. If the moles of reactant product are same, then we have no units of Kc. But if we have unequal moles of reactant and product, then there will be a unit of Kc. Okay, let's take the example, right? For example, there is a reaction between hydrogen and iodine, and it will also obviously be a reversible reaction, right? So it will form 2Hi. Now you can see it is also a balanced reaction, right? So if you want to write the Kc, we know basically first we will write the moles of product. The moles of product are 2, and the moles of reactant also 1, like 1 plus 1 is equal to 2. It will be 2, and we know that the unit of mole, like we have taken here molar concentration, so the unit of molar concentration is mole per dm cube. So there are 2 mole per dm cube, so we will write mole per dm cube, mole per dm cube. Over here again mole per dm cube, and here 2 mole per dm cube, and it will get cancelled. So now what will be left? Nothing will be left. So it means that there is no unit of Kc, because the moles of reactant product were same. That's why. Now let's look at here. For example, we had the example of Haber-Bosch process, which is nitrogen plus hydrogen. It will form 2H and H3. So here it will be Kc is equal to, here we have 2 moles and here we have 4. So here we will write 2 times mole per dm cube and mole per dm cube. Or here we will write 4 times mole per dm cube, 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 and 2 mole per dm cube cancel up with 2 mole per dm cube. Then what will left? Kc will be equal to mole 2 minus 2 dm cube 6. This will be left. So here we will get a unit of Kc, because we have unequal moles of reactant and product, right? So I hope this is clear. Now let's talk about the concentration of equilibrium, right? If we have, for example, molar concentration, it will be, the Kc will be equal to Kc, right? And here we will write the Kc by Kc is equal to, for example, consider we have a reaction A plus B C plus Dd, right? This will be basically a chemical reaction, right? Here now we know that the active mass of product upon the active mass of reactant, right? So here product is basically C. Here we will write bracket C D, and here, because we show molar concentration by the square bracket A and B, right? This is for the molar concentration. We also show the concentration of chemical equilibrium by partial pressure, by partial pressure, which is denoted by basically by Kp. Alright, so now here Kp will be basically equal to P. Now here C upon C multiply by P D upon D, and here P A. It will be this, right? We have this equilibrium, like the unit of equilibrium in mole fraction as well. Mole fraction, and it will be equal to Kx, which will be equal to x dd multiplied by x cc x a x b. This will be for the mole fraction, and we also calculate the concentration of equilibrium in terms of number of moles as well. And for this, K will be equal to Kn, and now here N basically N d multiplied by N cc and A multiplied by N BP. This will be the formula when we use this unit, right? So I hope this is clear to you till here. If you have any kind of queries, you can ask me in the comment section, and I'll be very glad to answer you guys.